Hello everyone. Here, this is Azita, and in this session, I'm explaining IP subnetting with an example. So we know that the subnetting is the result of shortage of IP version for addresses. So what the solution was to introduce private IP addresses like the one that I have written in here. Private IP addresses for class A are 10,000 with 255,000 subnet mask. And for private class B, we have reserved 172.16.0.0 to 172.31.0.0 with prefix 16, which is 255.255.0.0. And for class C, we have 192.168.0.0 with prefix 24, which is 255.255.255.0. Okay, in this example that I have created, you can see two routers of R1 and R2, and to R2 there are 1 and 2 networks are connected. In say that we call these networks Hatfield. In Hatfield we have a router R2 is connected to a switch and 4 computers, 4 PCs, and we call that C, network C. And R2 also is connected through an interface to a server, which we call it D. And then we have a point-to-point connection from R2 to R1. For this point-to-point connection, we need only 2 IP addresses within the same range. And here we have R1 connected to London. R1 is the London network and is connected to a LAN with requirement of 8 PCs, as you can see in here. And R1 from other side is connected to another switch with 2 servers. Okay, so the IP address given to us is 192.168.1.0 prefix 24. We can say that this is a small office, and we have in total 1, 2, 3, 4, and 5 range of addresses to assign to our LANs. So I said in here, I need to assign IP addresses to 5 LANs. Okay, so these 5 LANs are, as you can see, A, B, C, D, and F as shown in that diagram. So what we need to do now is that to make a decision of subnetting. In order to subnet, based on the theory, we cannot touch the network section of the IP address, but we are allowed to borrow bits from the host part in order to add to the network part. Here, as you can see, the number is 192.168.1.0 with a subnet mask of 255.255.255.0. So 192.168 and 1 are the network portion of this number, and 0 is the host portion. If you ask me that where this prefix 24 is coming from, then I can answer you that if we convert the subnet mask into binary, we'll see that 255 is 8 ones. So 8 ones, another 8 ones, 16, another 8 ones, gives me 24. So that therefore this number of 24 comes from there. We know that an IP address has a length of 32. So if we take away 24, which was this prefix, from 32, it gives me 8. So 8 is the remainder for the host portion. So now let's make a decision of how many bits we are going to borrow. So 192.168.1, all the zeros in this in binary are the field, or all those zeros are the field that I have to make a decision of how many bits I'm going to borrow. So I'm going to remind you that bits value starting from 1, which is 2 power of 0, 2 is 2 power of 1, 4 is 2 power of 2, 8, 2 power of 3. So let me just write it down here. 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 4, 2 power of 3, 2 power of 4, 2 power of 5, 2 power of 6, and 2 power of 7. In total, we have, as we mentioned before, 5 networks we need in that diagram. 1, 2, 3, 4, and 5. So if I borrow only 1 bit in here, it gives me only 2 networks, but I need to feed 5 networks. So this is not the correct one. If I borrow 2 bits, 2 power of 2 gives me 4. So 4 networks is not enough. 5 doesn't fit in that. But if I borrow 3 bits, as you can see, the 2 power of 3 is 8. So therefore, 5 networks of my requirement in this example fits in here. So therefore, I borrow 3 bits. So this is like, the 0 parts of the host part. Borrowing 3, it gives me, so I borrow these ones here, and that would be part of my network now, and that would be part of my host. So now let's see, 2 power of 3 is equal to 8, means that I can create 8 range of IP addresses, and in each range, so let me just write in here, 8 range of IP addresses, or 8 networks. Okay, and then in each range I have 2 power of 5, which is 32, minus 2 numbers for host, means that in each network I can have 30 hosts. Why we take away 2 from it? Because in each range, 1 is taken for network address and 1 is taken for broadcast address. And these are the numbers that are reserved and cannot be used to assign to a host. So now, if I write it down, you can see that my original number was 192.168.1.0 prefix 24. But now the new number that I've created out of that, borrowing 3 bits, is 192.168.1.0 with prefix 27. Please note that those 2 numbers are not the same anymore, because in the new number with prefix 27, we have 27 ones in here, and the subnet mask is 255.255.255.224. So now, in this table that you can see, I have created 8 range of IP addresses that we generated. So remember, we had 1 range of IP address, 1, and borrowing 3. Now I'm creating 1, 2, 3, 4, 5, 6, 7, 8 range of network addresses. That's very important to understand. So now, the question is how I calculate this range of IP addresses. For that, there is an easy way without you converting the numbers into decimal, into binary, and that is by calculating the magic number. The magic number is always calculated by taking away the bits that you have borrowed, which in my case is 224, taking it away from 256. As you know, each IP address is from each octet of IP address is a number from 0 to 255. If you count 0 to 255 based on these values that we said, is 256. Okay, so always remember that you have to take away the new subnet mask, the parts that you borrowed for subnetting from 224, and then you get into this magic number 32. So what's the use of magic number? Magic number is when you write the first IP address, which is 192.168.1.0, means from 0 to 31, 32 number is the number of available in this range. Okay, so let me just make my explanation a little bit easier. 192.168.1.0 is the first one. Then you add 32, you get into that number. That is your next range. And then you add another 32 to it. You get into 64, another range. You get into adding 32 to 64. You get into 96. 96 plus 32 is 128. 128 plus 32 is 160. 160 plus 32, 192. And finally, 192 plus 32 is 224. Okay, so these are the network addresses in each range. These are the network addresses. Then we write the broadcast addresses. So you can see that the broadcast addresses are here. For each range is one number before the next network address. So here is 31 and the next address is 32. Here is 63 and it has the next range. It starts with 64. So this is a pattern that you can see that each of these broadcast addresses are one less than the next network address. Okay, so when you figure the magic number, then writing the range of IP addresses are quite easy. So here we have all those IP addresses. So now I'm going to assign the IP addresses. So what I say is that I'm going to give this one for my network A, this range for network B, this range for network C, and this range for network D. Remember our F network here, can you see that? So this is A, B, C, and D, and F. Okay, the F was point to point. I'm going to keep that and explain it later for you, but I'm going to reserve that for it. Okay, so now let's assign IP addresses to network A, starting from 192.168.1.0 to 31. So A for me is this network. So I chose the red in here. I'm going to keep red. So guys, for these computers, so A, for the PCs, PC 1, I'm going to give 192.168.1.1 prefix 27. 192.168 for PC2. I'm going to give 192.168.1.2 prefix 27, and I have to give one IP address. I can give one IP address only for management to that switch, for switch. I'm going to give 192.168.1.3.27, and for my interface of a router, so if say that FA00 of the router R1, I'm going to give 192.168.1. I'm going to go with the largest number in that range. The largest number in that range is 1 before 31, because 31 is the broadcast address. So I'm going to give 30 in there. So here I have given IP addresses to all the devices in my network A. Now I'm going to do the same for network B. So let's choose another color, network B. So I have 8 PCs in there. So I'm going to choose this range of IP addresses that I've written in here. For B is starting from 32. So 192.168.1. So 30, starting from 30, said 32. So 33, 33, 34, 35, 36, 37, 38, 1, 2, 3, 4, 5, 6, 39, and 40. So all of that are the IP addresses of the 8 computers. But I'm writing it in that way for you because of for you to learn. But I could write like this: 192.168.133, 240 with prefix 27 for those 8 PCs in there. Then for my switch, so these are PCs time 8. And then for my switch, I'm going to reserve an IP address of 192.168.141.27. And for my this interface R1, say that FA01, I'm going to give 192.168.1, 1 before the broadcast address, which in my case is 1 before that is 62.27. And in that way, I have allocated all the IP addresses in that range. Can you note that here the IP addresses are all different from each other, and the subnet mask of prefix 27 is the one that defines now the new subnet mask instead of 24, which was before. And now for my C again, network C, so let's change the color in C. I have 4 PCs, so I'm going to take this range from 64, 192.168.164. So I'm going to give to 4 PCs 192.168.1. So 64 cannot be used because is the network address. So I'm going to choose the next one, 65, 66, 67, 68 to 688, prefix 24 for 4 PCs required in here in Hatfield one. And for my switch, I will give 192.168.169.27. And finally, for this interface, R2 safe FA01 interface, I'm gonna give 192.168.1. I'm gonna decide to go with the largest number in that one, which in this case is 94, because 95 cannot be used, is the broadcast address. So, and for D, now the next one is D, which is only one IP address is required. I'm going to give it from this network. So let me just change the color from this network. So for D, this is gonna be only one server, which the IP address is 192.168.1 and 90, as you see 90, where was that? Oh, okay, 96 is the network address. I'm gonna use 90 number after that with prefix 27. So now this is for here, this one are for there, and all the IP addresses are dedicated except this IP address of connection of those interfaces from R1 to R2, which are point to point. For point to point, let me see what are we gonna do. So guys, when we have a point to point, means only 2 IP addresses is required. So if this is a connection of a router, this is a router is connected to another router through point to point. Point to point. So we need only 2 IP addresses, okay? So for that, if I use one range, let's go to range 8, I'm wasting 30 host numbers. So the solution for that is that I take 192.168.1.224 in here, as I've written in here, and then I borrow some bits again from the host part, and I jump from 27 to /30. In this case, if I write it down, 1, 2, 3 was prefix 24. So that one was 27. Now I added and borrowed another 3, and it made it prefix 30. Okay? So for point to point, we need prefix 30. So let's see what is the magic number for prefix 30. The magic number is 4 and is calculated by taking away 252 from 256. Where did I get the 252 from? So is 1 all ones, 255. So all ones in here is 255, all ones in here is 255, and all ones in here is 255, and here is 252. If you count, there are 30 ones in here in this subnet mask, and then you take away 252 from 256, and the result, the magic number, is 4. Now we know that we have to add to each of these network addresses 4 in order to get the range of IP addresses. So my first range is 192.168.1.224, the one that I chose to do point to point calculation with prefix 30. The next one is adding 4 to a 228. In each range, as you can see, I have 224, for instance, for network address. 227 is the broadcast address. This is network address, and there are two available IP addresses. One is 225 and one is 226 that I can give to my point to point. So here for my point to point, finally for F, I give this number 192.168.1.225 prefix 30, and for R1 end here for R1, and for R2 point to point end I'll give 192.168.1.226.30. One thing is important for you to know, that both of them, since they have direct connection to each other, they are part of the same network. So in that way, the IP addressing is completed for the given network, and all the IP addresses are assigned. You have three, can you see that? You have three more range of IP addresses for future expansion in here. And also for point to point, you have 7 point to points number available for future expansion. Okay, I mean here, for instance, like if I have a router and only one server, I can give a point to point number, which in my case is prefix 30. I hope that with this explanation you can understand the usage of IP subnetting. This practice is very common in real world situation, and I don't think that you get into a job with a LAN that they have not used the subnetting. For IP version 6 is also subnetting, but this one is concentrated in IP version 4. So thank you very much for your attention. I'll see you in the next video. Bye.